Ooh, 9 o'clock and I'm drinking coffee. Oh my god, what is the matter with me? I do math, I drink coffee. It's like, oh my god. Alright, I got a problem. Let's see. So, now, oh, right. So this is a great problem because this is, I've seen this on the SAT more and more. They don't give you the B, okay, but they want to know when is it going to have a one real solution. So this requires you to remember what a discriminant does. A discriminant allows you to determine whether or not you have one solution, 0 solutions, or 2 solutions. You've only got those 3 options. Okay, so remember, quadratic can hit the x-axis twice, it can hit it no times, or it can bounce right off and hit it once. Let's go a little closer there. Okay, now it wants to know what value of B can I change to so that I can actually make it hit once. Okay, not these 2, but just this once. So what this requires then is that I need my discriminant to equal 0. Okay, my discriminant has to equal 0 in order to have one real solution. Okay, you have to remember this. If you don't remember it, then this problem is completely inaccessible. Okay, got to remember this part. Now, the good thing is that I don't know B, but the good thing is I do know A and C. Okay, now my A is 1 and my C is 64. So what I do then is I go and put in everything that I know already. So that's 4 times 1 times C. Okay, and now I'm going to figure out what those values are. Okay, so B squared minus, what's 4 times 64? I do not trust myself. That's 256. Okay, so now this is just like, where are you? Just like this guy. Okay, I am solving this now because all I got to do is move 256 over to the other side, and he'll become positive though, so I don't have to worry about i's. Okay, now all I got to do is take the square root of 256, but remember I'm going to have a positive and a negative version. So let's see, 256. So square root of 256 is 16. There you go. So B can equal plus or minus 16. So if this guy was x squared minus 16x plus 64, I would have a graph like that. If it was x squared plus 16x plus 64, I would hit the x-axis. Oh, I know, you're saying you don't believe me. Okay, you don't believe me. All right, well, let's do this quick. X squared plus 16x plus 64. Let's see if we can see that guy. Oh, look at that. Hits the x-axis once. Okay. Well, what's the other situation? Let's move over to here and go minus. Okay, graph it. Yep. So in both situations, I hit the x-axis once. One over here and once over here. Okay. And that's why we have a plus or minus. Okay, so these are true. All right. You can always use the graphing calculator. If you can use the graphing calculator to verify that. Okay, so now we're going to be using the graphing calculator here to verify when these guys intersect. Okay, so what we do is we use the beautiful qualities in these lovely graphing calculators, and we're going to figure out where these guys intersect, and we're going to use some of the functionality of the calculator. So my first curve is the y1 here, and my second guy here is y2. Okay. And I want to know where they intersect. Where they intersect is the solution. Okay. So I'm going to go ahead and type that in. I'm going to go 4x. Y1 is going to be 4x squared plus 3x minus 5. That's 1. And then x plus 3. All right. So those are the two. I'm going to have a blue line and then a red line. And then we're going to see where they intersect. Now, if I look at this guy, now I'm going to do a zoom standard. Okay, there's 1. Okay, there's 2. So x is approximately here, x is approximately there. Now that approximation means that I don't actually know, okay, let me see if I can zoom in here. I don't know exactly where that is. You can see that it's in between -1 and -2. And what my calculator will do is it will figure that out exactly. Okay, so I'm going to go ahead and I'm going to go to second calculate. Okay, now these calculators, if I go second calculate, I can go to where they intersect. It also does other things too, which is really cool. But right now we're just interested in that intersection feature of the calculator. So again, it's second trace. You might want to write that down on your note card. And when I go intersect, it's going to ask me some questions. It doesn't know which one it wants me to do. So what I got to do is, it shows me on the blue curve. And what I'm going to do is, I'm going to get close to the first intersection. Okay. Now I'm going to call this guy the first intersection. I'll call him the second. So I go here. And then it asks, the second curve is right there. Now what I want is the intersection in between those two. And when I hit enter, okay, then it asks me for a guess. And what the guess means is that I'm going to move that guy to roughly where it actually is. And this is really just good for like really complex things where there could be lots of intersections. This guy is kind of simple. There's only 2 locations. Okay, so right there, it gave me the intersection at x equals -1.686. -1.686. Okay, now that's good. Okay, if you were an engineer, that is a really good answer. All right, and you didn't actually use any algebra, you just used technology. So now we're going to get the second. So here we're going to do it again, second calculate. We're going to go down to intersect, and then we're going to start over, but we're going to focus on the second point, okay, or the second intersection. So here I go to the left there, I'll go to the right over there, and then the guess is going to be roughly right about there, and I get positive 1.186. 186. Okay, and you'll notice again these are just approximations. Okay, just approximations. Okay, all right. Now, if I would have had to figure those out, I would have had to use the quadratic formula and set this guy equal to 0, and that would have been a longer problem for sure. All right, 25, we're at the 7-minute mark. Okay, so we got a cubic polynomial, and we're now in unit 3. And this guy, I have no idea what he looks like, but I do have some vocab. Excuse me. The degree of the polynomial is 3. Is that true? Got third? No, it's not. Unfortunately, you see that 5? It's actually a 5th degree. This thing's out of order. Okay? So this guy's completely out of order. So A is not true. It's a 5th degree polynomial with 4 terms. So, written in standard form, the polynomial is this? No. This 7x plus 5 would go to the front, and I don't know what happened to the 7 there. The polynomial is a trinomial? No. This has 4 terms. So, 3 terms would have been a trinomial. Okay, and so the leading coefficient is 7. Well, right now it's 1. But if this guy goes to standard form, then this guy would be in front, so 7 would be the leading coefficient. So the answer is D. Okay. Oh, let's see, where are we at? I think between all 4 of these, probably just wait and make one more video after this one.